completely sensitive. It will explode. No, it won't, he said. Offer me a chance to go for that. The thing is, it might be tomorrow, it might be during this transmission, and it would shimmer like a second sun above. The James Webb Telescope has actually identified an unforeseen 250% extension in the splendor of Betelgeuse, the red star arranged at the shoulder of the Orion star gathering. This whimsical approach to acting has ignited excitement for a fascinating presentation. Some suggest the flood in splendor could indicate Betelgeuse is preparing to go supernova, yet the exact timing remains uncertain. Experts conjecture it could occur in a little while. Join us as we explore the depths of space and unravel the mysteries surrounding this magnificent giant. Betelgeuse has the potential to reshape how we understand the universe. Despite its name not being widely known, you've probably appreciated its quality. A brilliant rosy glow shining brightly at the shoulder of Orion, a striking star grouping. Betelgeuse's magnitude is staggering. If placed at the core of our planetary system, its outer surface would extend beyond Jupiter's orbit. This giant star, easily observable, continues to captivate us. Unlike most stars, Betelgeuse changes visibly over time due to its proximity to our system. Named a semi-regular variable star, its brightness fluctuates consistently, moving toward a possible extraordinary breakdown in a supernova explosion. Recently, Betelgeuse has become even more captivating due to astonishing variations in brightness. These fluctuations include a significant surge on May 20, 2023, when scientists observed a stunning 142% increase in brilliance, followed by an update showing a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, noted that Betelgeuse now ranks as the 7th brightest star in the night sky, climbing 3 spots from its usual 10th position. From the southern hemisphere, Betelgeuse shines brightly in the early evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's significance. It offers a rare opportunity to study the final stages of a massive star's life, providing valuable insights into red giants' behavior before they explode as supernovae. When Betelgeuse ultimately explodes, it could become extraordinarily bright for about a week, potentially creating shadows at night. This prospect excites both amateur and professional stargazers alike. Heidi Morris, an expert at Los Alamos National Laboratory and president of the Padaro Astronomers and Cosmology Club, noted the enduring interest in Betelgeuse's brightness fluctuations, a phenomenon observed for centuries by various cultures. Currently, Betelgeuse's brightness cycle lasts around 130 days, significantly shorter than its usual 400-day cycle. These rapid changes provide astronomers with a unique opportunity to study this stellar phenomenon in detail, shedding light on the final stages of a star's life. The remarkable behavior of Betelgeuse began in 2019, when it violently ejected part of its outer atmosphere. These fluctuations in brightness are unusual for Betelgeuse, raising questions about whether it will explode into a supernova. According to a paper written by Dupree and other researchers from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle. Since the Great Dimming, Betelgeuse has exhibited altered behavior regarding its light and radial velocity. Despite its unpredictable nature, Betelgeuse remains a massive red supergiant star undergoing the final stages of rapid evolution. As it exhausts its fuel, the core will collapse under its immense mass, resulting in a supernova explosion that could outshine entire galaxies. The timing of this event is uncertain. As noted by Dr. Pierre, a professor of cosmology at the University of Portsmouth, predicting supernova events remains challenging due to limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, continuously progressing through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon in its core, a process that takes millennia. Eventually, it will transition to fusing heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and potentially forming a black hole or neutron star. While some speculate about Betelgeuse's imminent explosion, Historical records show it has been growing redder over the past few centuries, suggesting it may take considerable time before it goes supernova. NASA estimates suggest that Betelgeuse is not expected to explode for another 100,000 years, offering reassurance that its blast is unlikely to occur within our lifetimes. Despite the uncertainty, Betelgeuse's behavior continues to fascinate researchers and drive advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to remain open to the mysteries of the universe as we observe and learn from this remarkable star. To potential results. Even as we recognize the unrealistic probability of witnessing Betelgeuse's blast within our lifetimes, staying aware of its progressions might prompt further logical breakthroughs, reminding us to keep hope alive for new discoveries in the universe. It's critical to comprehend that our perceptions of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old. Hypothetically, Betelgeuse may have already exploded, and we wouldn't yet know about it. While this possibility exists, it is far from certain. History has shown us that our assumptions in cosmology can be challenged. Prior to 1987, astronomers believed only red supergiants could undergo supernovae. However, that year, a massive blue star in another galaxy exploded, surprising the academic community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of stellar phenomena. Regardless of the absence of an imminent blast, Betelgeuse's current behavior is captivating. Its fluctuation between dimming and brightening reveals fascinating physics. The fact that stars pulsate on human timescales is remarkable. While Betelgeuse is currently much brighter than expected based on its usual multi-year cycle, there's hope it will eventually return to this rhythm. However, it seems to be struggling to do so. Recent observations suggest Betelgeuse may be in a late stage or nearing the end of its core carbon-burning cycle. This stage involves the conversion of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, scientists predict a core collapse leading to a supernova explosion that could occur within a few decades. However, determining Betelgeuse's exact evolutionary stage remains challenging, and uncertainties persist. The prospect of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning phase can last up to 1,000 years. Moreover, the study suggesting an imminent explosion has not yet been accepted for publication. Nonetheless, considering the potential for Betelgeuse to become a supernova is thrilling. It would be an extraordinary event, visible even during the day for several days. When the event arrives, the initial signs of the supernova's appearance will be subtle yet unmistakable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of stellar debris. Betelgeuse will gradually grow brighter in the night sky, potentially reaching peak brightness 10,000 to 100,000 times its usual luminosity within just a few weeks. This spectacle will amaze anyone fortunate enough to witness it, marking a pivotal moment in astronomical history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, condensed into a single point of light. Remarkably, this brightness would be visible during daylight, creating dramatic shadows at night. Predictions suggest it could be 15 to 20 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's blast would linger for around 100 days, captivating space enthusiasts and offering a unique opportunity to observe its aftermath closely. Fortunately, Betelgeuse's supernova would not pose any threat to humanity, as it is still significantly far away. Optics and telescopes would allow us to observe the event for an extended period without harm. However, such a dramatic event would not go unnoticed. Supernovae were often interpreted as ominous signs, and Betelgeuse's demise could inspire fascinating reactions globally. Astronomers believe it may reignite widespread interest in astronomy, awakening people from their cosmic ignorance on a global scale. Betelgeuse is not the only red supergiant in our universe. Others, like Eta Carinae, could explode before it does. In reality, our Milky Way should witness a supernova approximately every century. However, we haven't seen one in the last 400 years, even though we've observed remnants of past explosions. This suggests we are overdue for a spectacular stellar event. It's only a matter of time before the next star puts on its grand show for the universe to witness. Betelgeuse's history is rich with significant events, including the dramatic dimming in the fall of 2019. This sudden decrease in brightness puzzled astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily spot Betelgeuse from their backyards, providing valuable observations for researchers to gain a deeper understanding of the star and its dramatic changes. Scientists rely on observatories like Hubble. The interest surrounding Betelgeuse's dimming and potential explosion has captured the imagination of many. The fascination with Betelgeuse has been a continuous source of inspiration for both amateur astronomers and professional scientists alike. The star's eccentricity, particularly its erratic brightness fluctuations and mysterious dimming episodes, has made it a prime subject for study. Observing these changes not only offers insights into the nature of red supergiants but also provides valuable data about stellar life cycles, the processes leading to supernovae, and the dynamics of massive stars nearing the end of their lives. Betelgeuse's recent surge in brightness in 2023 has reignited global interest in this cosmic giant. The star's peculiar behavior raises intriguing questions about the timing and nature of its eventual supernova event. Some astronomers are hopeful that Betelgeuse's brightening is a sign that the star is nearing the end of its life, while others caution that it may simply be undergoing an unpredictable but normal phase of evolution. These fluctuations in brightness offer a rare opportunity to observe stellar behavior in real time, allowing astronomers to test theories about the evolution of massive stars and their ultimate demise. Despite the uncertainty surrounding the exact cause of Betelgeuse's recent activity, the star's history continues to provide clues. As previously mentioned, Betelgeuse has experienced significant variability in brightness over the past few centuries, and its periodic fluctuations are believed to be part of the normal life cycle of a red supergiant. However, the sheer magnitude of the current brightness surge has sparked excitement among the scientific community, prompting further investigations into whether these fluctuations are precursors to a supernova or merely the star's natural oscillations. As research continues, one thing is clear: Betelgeuse remains a phenomenal subject of scientific study. While its eventual explosion remains a distant possibility, the ongoing monitoring of this stellar behemoth is expected to yield valuable data. By studying the behavior of stars like Betelgeuse, astronomers can refine models of stellar evolution, providing insights into the life cycles of stars and the cosmic processes that shape our universe. Meanwhile, skywatchers will continue to marvel at the bright, fluctuating glow of Betelgeuse. Whether it's dimming or brightening, the star's unpredictable nature ensures it remains a captivating target for both amateur and professional astronomers. As we continue to observe its evolution, the potential for a spectacular supernova event adds an element of cosmic drama to an already extraordinary celestial spectacle. Ultimately, Betelgeuse's eventual fate will have a profound impact on our understanding of the universe. While we may not witness the star's final explosion within our lifetime, the knowledge gained from studying Betelgeuse and other massive stars will shape our understanding of the cosmos for years to come.